سڵاوتان لێبێ بەڕێزان هاتمە وڵاتان بۆ تەواوکردنی بابەتی دەرسی ڕابردوو ژیار حسابەکانمان تەواو کرد ئەو مەڵتیپل چۆیزانەشمان حەل کرد وتمان ئەوەشیان هۆموەرکتە. And now let's learn something really important. We need this kind of relation, the relation between, pH with H3O, pH with OH, pH with POH for chapter 3 and chapter 6 also. So let's learn how they change together. Are they direct or indirect, inversely, or they're directly proportional? As you remember, we have two rules. As I said, pH equals to negative log of H3O, and POH equals to negative log of OH. Okay, we have these two rules. Let me write them from the first. pH equals to negative log of H3O. We need this space, okay, and POH equals to negative log of OH. Nice. Let's see how's the relation between them. pH and POH, they are inversely proportional. They are inverse. Okay? They are inversely proportional. Good. OH and the H3O, again, they are inversely proportional, indirect. pH with the H3O, they are inverse again. OH with POH, again, they are inversely proportional. Good. So these are inversely proportional to each other. So how about the direct relations? Look, H3O with OH, they are direct. And the pH with the OH, they are direct. They're direct. They're direct. Okay, just like this, you can learn the relation between them. Inversely proportional, inverse, 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 and these two are directly proportional. Good. Okay, for what we need this kind of something like a mapping. Okay, so we have some sort of questions like which of the following has the maximum or minimum H3O, OH, or POH? We will answer all of them by pH value. Example, if I say, which of the following has the maximum concentration of OH? Just wait, mister. Maximum OH. What's the relation between OH and pH? They are direct. So maximum OH, it means maximum pH, greatest pH. Which of the following has the minimum example POH? Wait. We don't answer this question by POH. Minimum POH, the relation between POH and pH, they are inverse. They change inversely to each other. So minimum POH, it means maximum pH. Just like this. Okay? And then let's learn how to plot, how to use different substances in a scale of pH. The scale of pH at 25 Celsius degree, okay, for different substances, at the same concentration. Okay, at the same concentration. The scale is ranged between 7. The scale is ranged between, okay, 0, 7, and 14. 0, 7, 14. Here, this is acidic territory. This is for the acids. This one, neutral. Example, H2O or neutral salt. You will learn what we mean by the neutral salt. Good. And here we have a bases. Great. Acids, bases, neutral. For the acids, we have the following acids. Example, H2SO4. Okay. We have HCl HBr, and so on. And the weak acids like HF or H2CO3 or H3PO4. Good. As much the value of pH is decreased, acidity will increase. Acidity is increased. This is, we will use this scale in terms of the same concentration. That's why it means they produce hydronium ion. The one that produces maximum hydronium ion will become the strongest acid, or the one that produces maximum OH will become the strongest base. Okay, so now, mister, we have the weak acids. These are weak acids. No matter if the acid contains 1, 2, or 3 hydrogens. The weak acids, all of them are located beside of H, smaller. This is the position of the weak acids. No matter if the acid contains 1, 2, or 3 H. Example, HF or H2CO3 or H3PO4. All the weak acids are located here, okay? And now we have two kinds of the strong acids. Some of them, they contain 2 hydrogens. Some of them, they contain 1 hydrogen. The one that contains 1 hydrogen is located between 0 and 7. It's here. Strong monoprotic acid. Example, HCl, HBr, HI, HNO3, and so on. Okay? Good. How about here? How about here? Okay, here, this is the house of sulfuric acid, H2SO4, strong diprotic acid. Good. لەگەڵم بە تخۆبەوەندە دووبارەکەینەوە دەی. I'm going to repeat the whole things from the first. The scale of acid is ranged between 0, 7, the scale of pH is ranged between 0, 7, and 14. For the acids are ranged between 0 and 7. This is for the acids. We have the following acids: H2SO4, HCl, HNO3, so on, and the HF, H2S or H2CO3 and H3PO4. These are weak acids. Anasina, weak acids. Okay, mister. Weak acids, by the way, all of the acids, they have smaller pH compared to 7. By the way, as much as the pH value is decreased, the strength of the acid, is increased, or acidity is increased. The one with the smallest pH will become the strongest acid. Good. Look, the weak acids, that means they have greatest pH compared to the other acids, or among the acids, weak acid has a greatest pH. Okay? Then, this is for the weak acid. Then, in the middle, I mean 0 and 7, we have strong acid with one H, monoprotic, strong monoprotic. And the strong diprotic acid is located beside of 7, beside of 0. My God, what's going on, okay? Here, H2SO4, strong acid diprotic. Okay? Tamam? 0, 7. Beside of 0, the strongest acid, which is diprotic acid, H2SO4. Beside of 7, we have weak acids, no matter if they contain 1H, 2H, or 3H. H2CO3, H2S, H3PO4, H3PO3, so on. In the middle, we have strong monoprotic acid like HCl, HBr, HI, and so on. How about the bases? Okay, for the bases, as the pH value is increased, basicity or alkalinity is increased. Good. Basicity or alkalinity is increased. Okay, bases again are ranged between 7 and 14. We have the following bases: NH3, NaOH, and the family, CaOH by 2, and the family. Good. Weak bases like CH3NH2 or C6H5NH2. These are weak bases. Weak bases are located beside of 7. They're here. This is for the weak bases. By the way, pH of the bases is greater than 7. pH of the bases is ranging between 7 and 14. Here we have weak bases like the following things. How about the strong bases? Okay, we have some strong bases with 1 OH, some of them with 2 OH groups. The one that has 1 OH, it's here in the middle, just like the acids. The strong with 1 H, it's in the middle. Here, the strong with 1 OH, it's in the middle. So the line says strong base 1 OH. It's here. Example, NaOH and the family. How about here? Strong bases with 2 OH. Strong bases with 2 OH. Example, we have CaOH by 2, BaOH by 2, and the SROH by 2. How about middle? In the middle we have H2O, which is neutral, or neutral salts. باشه واسه. باش. با یک ذره مراجعه بکنو بخیره. یالا. لەگەڵ من بعد check yourself. 0, 7, 14. Yalla. Someone tell me, here it's a place of what? Between 0 and 7. Mister. Strong acid 1H. Monoprotic strong acid. Can you give me some examples? Yep. HCl, HBr, HNO3, HClO3, and so on. Good. How about here? Look. Here, weak acids. Give me some examples. HF, HCN, H2SO3, H2S, H3PO4. Okay, cross HPO could be. As I said, there's no relation between the acidity and number of hydrogen. This one ionizes partially, so it must be a weak acid. How about here? It's for the strong acids again. Irritable strong acid. Okay, no problem. But this one is for diprotic strong acid. Example, H2SO4. Great. It's time for here. Yalla. Between 7 and 14. This is for the bases. Good? Tell me the position here in the middle. Okay, this is for the strong bases. Strong base with 1 OH. Example. Give me some examples. Okay. NaOH. SR. NaOH. LiOH. And so on. Good. How about here? This is for the weak bases. Weak bases like what? NH3, CH3NH2, and so on. How about here? This is for the strong bases again. Okay, but you know this is also for the strong, but no. This time we need to have 2 OH groups. Like what? Okay, BaOH by 2, SROH by 2, and so on. Just like this. Very good. And now try to combine the relations with the scale of pH here to solve too many different questions. For the last time, 0, 7, 14. Remember, this scale is used at the same concentration. At the same concentration at 25 Celsius. What do we mean by at the same concentration? It means, assume we have HCl here and H2SO4 here. The concentrations must be the same. Example, this is 0.5 molar, this is 0.5 molar. Then we will use the scale. But if they have different concentrations, then you need to calculate the pH value. They may switch their places. It's okay to have HCl here and H2SO4 here if they have different concentrations. Be careful. And you know how to calculate them. We have too many rules. The last two lessons, in the prior two lessons, I've explained them in a very long, nice way, detailed. Same thing true here. They need to have the same concentration. Example, if we compare NaOH with BaOH by 2, so which one has a greater pH? According to the scale of pH, our pH is Yatra, but they need to have the same concentration. Example, 0.5 molar, 0.5 molar. Good. But if they have different concentrations, they may switch their places. يعني دەتوانین ئەوە یەک OH هەیە لێرە بی ئەوەی دوو OH هەیە لێرە بی بۆ مەرجێ کۆنسنترێشنیان فەرقی هەبی. As you need to calculate the pH values for them then. يلا وەرنە لای ئێرە look, if they have the same concentration. Good. Let's solve the following questions. Let me have a sip of water. I'm sorry. Water, however, it's a tasteless thing on earth, but this is the most tasty thing. Yeah, right? ئەنگۆش پێتاوانی ینی ئاو ڕاستە بە خۆی دەڵێن تامینیە بەڵام بەتامترین شتیشە خۆشترین شتیشە ئاوی سارد کە تێنی دەبی لەگەڵەوەی دەڵێن it's a tasteless substance. Okay. بابێن ئەو پرسیارەی حەڵکەین. So chemists think like this, so about the water molecule. Okay. Look, from the following solutions, so we have some solutions here. Which one has the highest value of H3O? Wait. Highest H3O, if you remember. Maximum, minimum, H3O, OH, POH. We will answer all of these questions by what? By pH. Highest value of H3O, it means the relation between H3O and the pH is inverse. H3O and OH, they are inverse. So the relation is inverse. Okay? Highest value of H3O, it means lowest pH value. How to solve this? Wait. Try to have a scale. 0, 7, 14. Good. HBr. What's HBr? Strong acid. This is acid, it must be here. Strong monoprotic acid, it must be in the middle. Okay? I like to use different color. Okay, some color rather than this. I mean different colors. Okay. So it's a strong monoprotic acid, it's in the middle. This is A. How about B? NH3, it's a weak base. Weak bases are here. This is for B. H2C2O3, 2 protonia. No, this is a weak acid. Weak acids are here. This is C. Good. And H2SO4, strong diprotic acid, it's here. H2SO4 كليري تنسى فريا H2SO4 لبينا كيو مالي H2SO4 يا بيام ده لو ينزيك دبتو. إيه زي H2SO4 بس زماني قلت يا طبعا D. Okay, how do we know if they have the same concentration? Yeah, the question said if they have the same concentration. But if we have them in different concentrations, then you should calculate their pH values according to the rules. Never forget this. Okay, look, which one has lowest pH? Lowest pH, it means, okay, this is greater than 7, smaller than 7, smaller than this, smaller than this. So D has the lowest pH. D is correct. Another question, my dear. Look at the question here. Look, from the following solutions, we have some solutions. Which one has the highest value of OH? Highest OH. What's the relation between OH and pH? According to the relations, OH and pH, they were like this. They were like this. Okay? Got it even direct. Highest OH, it means greatest pH value. Highest pH. Okay, try to have a scale here. This is the scale. This is the scale of pH, 0, 7, 14. Good. NaOH, it's a strong base. Strong bases, if it contains one OH, it must be in the middle. 2 OH must be beside you, 14. It has 1 OH, so it must be here. Strong base. Okay, A. Then H3PO4, weak acid. Weak acid, it's here. B. How about it? NH3. NH3, it's a weak base. Weak bases are here. This is B. D H2SO4 ليري كاك أو مالي H2SO4 يا بياو نية دسكاتوي باش شبابي من D. If they have the same concentration. كورا if they have the same concentration يكسر H2SO4 دي إيرا بزمان دقلي. بالام if they have different concentrations دكري H2SO4 فريدينا إيرا. يعني فريدينا إيرا. Okay? تمام. If they have the same concentration كورا H2SO4 يكسر زي أليريا بقري دقلي تنبرين هذا. تمام. Which one has the highest pH? Okay. pH of D is close to 0, greater than this? No. So compare it to B. D has the lowest pH. We don't need this. Oh my God. I have wrote two answers of B here. Look at this. NaOH, it's here. Very good. H3PO4, it's here. Nice. This is a weak base. This is a weak base. C is here. Okay. Oh, it's here. So now the highest pH is A, which is close to 14. A has the highest pH value. About this, which of the following has the highest pH value? Okay, highest pH value. Just look at them. We have 3 acids with water molecule. Water pH is 7. This one pH is smaller than 7. pH is smaller than 7. This one, pH is smaller than 7. So water compared to acids, has a greater value of pH. Compared to acids, water has a greater value of pH, simply. But compared to bases, water has a smaller value of pH. Nice. So here, water has a greatest value of pH compared to the other answers. Okay. Which of the following value of pH represents the highest acidity? Highest acidity, it means lowest pH. Be careful. Highest basicity, highest pH. Highest acidity, lowest pH. Look, as the pH value gets closer to 0, the acidity must be increased. As the pH value increased and goes to 14, the basicity, alkalinity must increase. So now highest acidity, it means lowest pH value. Look at it, my dear. pH is 11. Good. Just wait. Our man here. 0, 7, 14. This is 11. Okay. Or A. pH is 5. 5 is something like here. Okay. This is 11. Nice. And the POH. Okay, mister, we need this in pH. So it must be turned into pH. pH equals to pH plus POH equals to 14. So pH equals to 14 minus 13. pH is 1. It's almost here. It's almost here. pH is 1. Okay, and now this one pH is 13. It's almost here. So the point is, we don't need this scale, by the way, my dears. We don't need this scale. Just know this. The highest acidity, it means lowest pH. So pH of 11, pH of 5, pH of 13, POH of 13, it means pH is 1. So we need this one. Be careful. Highest acidity, highest basicity. Try to have all the numbers in pH. I'll repeat this question from the first. Look, highest acidity, it means minimum pH. Okay, so all of them must be in pH. This is pH, 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 POH. No, turn this into pH, then solve the question. pH equals to 14 minus 13. pH is 1. So highest acidity, it means minimum pH. pH 11, 5. Okay, compared to B, A must be cancelled. Then B compared to C, pH is 1, cancelled. pH is 13 compared must be cancelled. So C has the minimum value of pH. This question. Which of the following has the lowest pH value? Okay, lowest pH value. Look at the answers, please. NH3, it's a base. Weak base, no matter, but the pH is greater than 7. H2O, it's a neutral substance. So pH is equal to 7. How about this strong base? Okay, pH is greater than 7. This one, COH by 2, it's a strong base again. pH is greater than 7. So these three have greater pH compared to 7. But this one, it has 7 pH. Okay, I mean pH of 7. So pH of H2O is smaller than the bases. As I said, these are bases: 14, 13, 12, 11, 10, 9, 8, 7. It's a neutral. So now bases, they have greater pH compared to water. So water has minimum pH compared to bases. Compared to the acids, it has a greatest pH. We have these two notes. Stay with me, my dear. Addition of dry ice. Dry ice, it means solid carbon dioxide. To what? To water, to H2O. Okay, the product will be what? H2CO3. I have explained this in the acid rain phenomenon. Carbon dioxide, the dissolution of CO2 in water results H2CO3. What is H2CO3? Acid. So acids, they increase H3O. They produce H3O. H3O is increased. If H3O is increased, then pH is what? Is decreased, and OH is decreased also. Okay? Tamam? Of course, POH must increase because of the relations. Nice? And the solution is acidic. Another one. Addition of sodium peroxide. Sodium peroxide. This is sodium peroxide. Na2O2. Addition of sodium peroxide to water. It will form NaOH. Sodium peroxide produces NaOH. Never forget this, my dear. Okay, the point is, look at this. Let me delete this. I'm going to write from the first. Addition of sodium peroxide. This is sodium peroxide. Na2O2. Okay, this is sodium peroxide. Wait. Okay. Sodium peroxide is Na2O2 because peroxide ion is O2 negative 2. Okay, this is sodium peroxide to water. If we add sodium peroxide to H2O, so the solution will become what? Will become NaOH, which is basic. This is a base. Okay, bases, they increase OH. If OH is increased, then pH is increased, and the solution will become a basic solution. Basic solution of NaOH, alkaline solution. So sectionی یکمان تا کرد. انشاءالله درسی دا به باسی سکشنی دوم دکم لسکشنی دوم پیتان دگمو. So اگر تان لبی رولکانی سکشنی یکم همولا برکند که Section 1, we will have something like a disturbing theoretical explanation, but it will be good. It will be good. Inshallah, I'm trying to simplify this as much as I can. هیوا دارم سر کوتوبن سوتان لبینی بیتن تاونی ده هاتو بخواتن دست بیرم خواتن اگر